I want to go ahead and share some information about the peer instruction flipped learning model that I've been using. Peer instruction was developed by Eric Mazur, a Harvard physics professor, in the early 90s. He noticed that a lot of his students were coming in with fours and fives on their AP tests, but yet were still just struggling with basic concepts. Out of frustration one day, he just finally said, turn to your neighbor and talk to them about it. And to his surprise, the classroom erupted into great conversations. From this, he's developed the peer instruction model that he's been using and has been sharing that around the world. He says education is really a two-step process. First, the transfer of that information, and then secondly, the assimilation of that information. And we as staff must make ourselves available to help students assimilate that information. After all, information is everywhere. Now, the whole idea of the peer instruction that we ended up merging with the flipped learning model to develop the peer instruction flipped learning model, which are two both individually are both powerful models, but I think it's even more powerful when they're merged together. For the most part, with the peer instruction, students attempt a multiple choice question on their own, guess if needed, share that answer with their question or the teacher. Then they discuss that answer with the peer, ideally with a peer that has a different answer than they do. Try to convince their peer of their answer and why. And then we repeat that process. Now, what's it look like in my room? Well, my students are come into my room, I put a question on the board, they sit there, they refer to their notes, try to answer it themselves. Then they go ahead and submit that answer to me. Then they turn to their neighbor and start talking and dialoguing. Some students really get into this. They're arguing, they're debating, they're emotionally involved in the whole process because they want to know if they're right or prove that they are right. They still don't know what the right answer is. I've not shared that. And then students share their answers with me again. Now, after they've shared it with me, depending upon the answers that I get, hopefully the answers from their initial sharing, where it was just themselves, to where they shared it after they discussed, there's an increase in how many people got it right. If there's still some confusion or misunderstanding, I'll go ahead and briefly go over the question and the answer and the reasons why, maybe highlighting some things that I know that commonly people misunderstand and clarify stuff. And then we'll go on to the next question. So, what kind of questions work well? But ideally, when you're looking at your peer instruction questions, when students answer the question the first time, you want 30 to 70% of the students getting it right the first time. It'd be nice if half your class got it right, 50%, and then half had it wrong, because then you can have great conversations. Typically, though, if you're less than 30% getting it right the first time, there's too few students in your class that have it right, so you're not going to have those good conversations that help people jump that bridge from not understanding to understanding. One of the reasons why peer instruction works so well, or fairly well, is that for me as a teacher or a professor, I made that jump from not understanding to understanding typically decades ago. My students that did understand it and get it right that first time typically made that leap from not understanding to understanding within the last 24 hours. They remember fresh in their mind what it took to get over that gap of not understanding, and they're much more likely and able to help their peers get over that gap to the side of understanding. Also, typically, if you are more than 70% of your students getting it correct the first time around in your class, there's not going to be good conversations because most of the students already have the correct answer. So you might want to just briefly talk about what it is and then move on to the next question. So what do some of those questions look like? Well, here's some from an algebra class. You're like, algebra, this looks like arithmetic. Yes, but if you're adding algebraic expressions, if you understand how to do it with numbers, that process then flows over into doing it with algebraic expressions. So if students are not using their calculators here, they should be able to get the right answer if they understand the process, and therefore be able to do it with algebraic problems. Sometimes it's just multiple choice with only a couple answers, and other times it's more of a true-false, maybe a numeric response, or occasionally an open-ended, and I'll sometimes do that in my upper-level classes. Here's an example. This is for my calc class. Notice there's no real calculations involved. It's just, do you understand the concept and what you would do? And this ends up coming from an old AP exam. So how do you find or develop those good questions? If the subject you're teaching happens to be an AP level course or similar to an AP course, you can often use some old AP exams to get good conceptual questions. If you happen to teach math, the CUDA software, if you just go to CUDA, K-U-T-A software, and Google that, that's not a free program, but it's fairly inexpensive and allows you to generate open-ended multiple choice questions very easy. It's a very powerful program. You might want to look at old tests that you've given, and you kind of identify which students or what types of questions that students struggle with. There's other ways too that I could talk about, but one way that is often used is the first time you go through the peer instruction process, you put up a good question. It's not multiple choice, it's open-ended. You collect all the responses from that initial gathering of students answering the questions. You do an item analysis of all the different answers that occurred. You take the top 3 wrong answers and and your correct answer, and there you have your multiple choice questions for the next time around, or multiple choice answers, I should say, for the next time that you teach it. So what's our peer instruction day typically look like? Students come in, peer instruction questions are up on the board. We go through the peer instruction process. And then if students happen to have any questions either from the video, they're often cleared up during that peer instruction process. If some of the problems that students were supposed to get done the day before, they didn't because they're working a little bit slower and they are doing it at home, I see if there's any questions that they have on that. And then students just spend the remainder part of the class working on their problems. If you're interested in getting more information, you can go to the peerinstruction.net or blog.peerinstruction.net. Or you can visit my website of troyfaulkner.com. So does the peer instruction flipped learning model really work? Well, let's take a look at some of the data that I've collected. Now, for my calc class, my pre-calc and my algebra 2, I've actually taught the course in 3 ways. Lecture, the traditional flipped classroom, and the peer instruction flipped learning model. You can see on average, the flipped classroom, traditional here in red, outperformed the lecture in blue. But you can see the peer instruction flipped learning model outperformed both of them. Same idea here. Oh, and both of these slides we're looking at proficiency. What we mean by proficiency here at Byron High School is that the percent of students that are at 80% on your test or above. So in this situation here, 97% of my students ended up getting 80% or above on that test. Here, 75% of my students ended up getting 80% or above on that test. Same information here, lecture in blue, traditional flipped in red, peer instruction in green. And you can see on average the peer instruction is outperforming all the others. However, there is a little bit of fluctuation in the data. Ideally, I'd like to see the peer instruction always above, but the data is what the data is. And here from my accelerated Algebra 2, I'm looking at test proficiency, and you can see that the peer instruction significantly is outperforming the lecture. Now you'll notice I'm missing the traditional flipped, and that's because during that year of doing that, I had a year-long student intern in my room teaching that class, and I did not feel like I could use his data. So here's the summary. You can see going from lecture for calc to the traditional flipped, my proficiency went up by 3.4%. However, going from lecture to the peer instruction model, it's up by 13.6%. My best situation that I've had is where my scores were up by 17.7%. Looking at pre-calc going from the lecture to the traditional flip was up by 6.5%. And going from the lecture up to peer instruction, my results are up by 11.3%. I've had some classes which have been up by almost 12.4%. And then for my Algebra 2, looking at lecture compared to the peer instruction, it's up by 12.8%, and my best results have been up by more than 15%. I also happen to teach introductory to statistics at Augsburg College to some adult students, typically in their 40s, who are working full-time. And here we're comparing lecture on the far left to still lecture, but videos being online, and you can see that that helped. However, on the far right is the peer instruction flipped learning model, and we're up by 5.5% for the overall course grade averages at the very end. And so it did make a big difference. Plus, when I've surveyed my students, 100% of my students at the college level prefer the peer instruction flipped learning model over lecture. They're very enthusiastic about it. At the high school level, I would say last survey I've had, about 92 to 96% really like the peer instruction flipped learning model compared to lecture. And 86% of my students have, at the high school level, have found that the peer instruction problems have really helped them understand the material better. Now, looking at Algebra 1, I don't teach it, but another colleague of mine does. We've not really seen any statistical changes up or down in that. One quarter might be better. The next time we teach it, it might be a little bit worse, comparing lecture to peer instruction. But it still does a good job of getting students involved in the learning process. In geometry, from looking at our failure rates before we did peer instruction to after we did peer instruction, our failure rates are down significantly. Also for geometry, when you look at the overall course grade, prior to peer instruction, the number of students or percent of students that got above 80% went from about 46 all the way up to about 54%. So it's a significant increase in overall course grades with peer instruction. And that's with multiple times of teaching it here and multiple times of teaching it here. So it's not just one class coming through. So what are some thoughts and reflections about this? We'll go into that in the next video.